Hi, Luke here from Technicamps with another session on the Introduction to Programming for Teachers, all based in the Python programming language. Today we're going to be looking at functions. So the contents of today's session are going to be functions as black boxes, implementing and testing functions, and then also parameter parsing. So functions as black boxes. A function is a sequence of instructions with a name. For example, we've used the round function that was used in chapter 2, and that function contains a set of instructions to round a floating point value to a specified number of decimal places. There are other functions we've used so far. We've used the print function, we've used the square root function from the math library, we've used the len function to work out the length of a string, and I'm sure if you go back through the other lectures, you'll see many other examples of times where we've used different types of functions. So how do you call a function? You call a function in order to execute its instructions. For example, the round function we call on the arguments here, 6.8275, and then with the second argument of 2, so it's going to round 6.8275 to 2 decimal places, giving us 6.83, and that value is going to be, the value returned by the round function is going to be assigned to the price variable. Okay, so by using the expression round 6.8275, comma 2, your program calls the round function, asking it to round 6.8275 to 2 decimal places. Okay, so to call the function, we write down the function name and we provide it with some arguments, potentially, depending on what the function does. The round function then returns the result back to us, where the program was, back to where the function was called, and your program resumes execution. So you've got some code, it's running line by line, blah, 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 blah. It reaches the round function, or the price equals round 6.8275, comma 2. We pass the 6.8275 and the 2 to the round function. The round function does its job. It computes that value to 2 decimal places, the 2 being 2 decimal places, the value we gave it. And then it returns the result of this calculation, the result of this rounding of 6.83 back to the caller, back to where it was called from in the code, and stores the returned value in the price variable. Okay, so here, this round function is called, the program runs off, does the rounding set of instructions, and then returns that value back to this area of the code, this line of the code, and assigns the value to price. Okay, when another function calls the round function, it can provide inputs, such as the values that we've given it in ours, 6.8275 and 2. And that's the arguments or the inputs that we've provided when we've called the function. So these inputs are called arguments of the function call. They're not necessarily inputs provided by a human user. They might be done during the code. And they are simply the values for which we want the function to compute a result. So for the rounding function, the first argument you provide is the number you want rounded. The second argument you provide is how many decimal places do you want it rounded to. Functions can receive multiple arguments, or it is also possible to have functions with no arguments. So the round function here has 2 arguments. The length function we've been using, we typically provide it with a single string and it returns the length of the string. There are others. The print function returns nothing and could potentially have no arguments. It just prints a new line. So there are lots of different... you can provide a function with sometimes multiple arguments, sometimes it has no arguments at all. The output that the round function computes is called the return value. Functions can only ever return one value. This one value is maybe a little bit misleading. It can return one thing. That thing could be a list of values, for example, or a tuple of values. The return value of a function is returned to the point in your program where the function was called. So again, the round function goes off and does its job, works out 6.83 and returns that here. And then that gets assigned to the price value variable. When the round function returns its result, the return value is stored in the variable price. Do not confuse returning a value with with producing program output, which is produced using something like a print statement. The print function happens to produce an output on the screen, but it doesn't actually return a value anywhere in your code. So if you ran a program that said value equals print 12 plus 4, it's not going to make any sense. The assignment's not going to make sense because this print function isn't returning a value. It's just providing output to the screen. They are different things. Okay, so this actually doesn't return a value, so we've got something that doesn't return a value plus 4, and that's going to get quite confusing, and you're likely to have an error thrown at you by Python. So this leads us on to the idea of functions being black boxes. If we think about a real-world application, we think about a thermostat. A thermostat is essentially a black box. What can we do with a thermostat? Well, we can set a desired temperature. The thermostat itself will turn on the heater or the air conditioning as required to reach that temperature, but we don't have to really know at all how the thermostat actually works. How the thermostat actually knows the current temperature versus its goal temperature, we don't need to worry about. We don't need to worry about what signals or commands or instructions the thermostat sends to our heater or air conditioner. All we need to know is that we can set a desired temperature and the thermostat will then do something which gets the temperature of the room up to the desired temperature. And that's our goal when writing functions. We want to write our functions like black boxes. We pass the function what it needs to do its job. Things like with a thermostat, I want to reach X degrees Celsius and then receive. The thermostat should provide some result back to us, receive some answer. The function, the black box, returns something to us after it's done its job. Okay, so your functions should be designed that you provide it with something, it returns something, but you don't really need to understand how all the bits in the middle work, right? I don't need to know how the heater or the air conditioner works, or how the interfacing actually happens. Just like when we've looked at the length function, I know that if I pass the length function as an argument a string, it's going to tell me how long that string is. I don't really need to know how it does that, I just need to know what I can provide it with and what it's going to return in those cases. The round function, I know if I provide it with a floating point value and a number of decimal places, it will return the floating point number rounded to that number of decimal places, but I don't really know how it does that. But that's fine. Okay, so here we go, the round function as a black box. You pass the round function its necessary arguments, 6.8275 and 2. It produces the result 6.83, but I don't really know how it's done that inside this black box, but that's fine. As a user of the round function, a programmer calling the round function, you don't care how it does the job, only how to use it and that it does do the job correctly. Okay, so we provide it with some arguments, it provides us with some return value, and I don't really understand what's happening in the middle here, but that's fine. It's doing its job properly, I know how to call it, I know what it's going to return. Okay, you may wonder how the round function performs its job. As a user of the function, you don't need to know, you just need to know the specification of the function. If you provide arguments x and n, the function returns x rounded to n decimal digits. Okay, so this kind of leads on to you designing your own functions. When you design your own functions, you'll want to make them appear as black boxes to other programmers. Even if you're the only person working on a program, making each function into a black box pays off. There are fewer details that you need to keep in mind if you represent your functions as black boxes. You only need to then think about how to call them and what they'll return. So that's really, really important in keeping your code easy to read. The maintainability of your code. Development of code in a team, if you're working with lots and lots of people, instead of everyone having to understand everything, as long as everyone understands how to call things and what they return, that's fine. They don't actually need to understand how they work. It's important for abstraction and top-down or bottom-up development. and there are many more reasons why using functions as black boxes is very useful. Okay, so then we move on to implementing and testing functions. A function to calculate the volume of a cube. So that's what we're going to make. We're going to define our own function which calculates the volume of a cube. What does it need to do its job, and what does it answer with? So we need to think about what information does the function require to work out the volume of the cube, and then how is it going to represent the answer? What is it going to return? So when writing or defining this function, the way we do it is we pick a name for the function. Typically you pick a sensible name, just like we did with variables, and again we're following CamelCases. So something like cube volume is a sensible name for a function which works out the volume of a cube. We need to provide our cube volume function with some argument. The argument we're probably going to provide our cube volume function with is the length of a side of the cube. So why don't we declare a variable for each incoming parameter, or each incoming argument. We're going to call this side length. That's a sensible name. And then we put all of this information together along with this def keyword to form the first line of our function definition. So we are defining a function. The function's name is cube volume, and the argument that the cube volume is provided with is side length. Okay, this line of code here is called the header of the function. Okay, so we've defined our function as cube volume with one argument, and that one argument is the length of a side of the cube. Okay, if you run a program containing just the function definition, then nothing happens. After all, nobody's actually calling the function. Okay, so this isn't running the cube volume program, this line, or even if we added a body to it, isn't actually running the cube volume function. It's just defining it. So at some point, someone has gone and written some code to define the length function. But it doesn't do anything until we call it. Okay, so if you run a program containing just a function definition, nothing will happen. You actually need to test the function, and for the function to actually be used, you need to call the function, right? So your program needs to contain the definition of the function, the user-defined definition, and then some statement that call or use that function, and then probably print something just to indicate that it's something's happened, right? Something useful has happened. Okay, so let's say we fill out the body of our cube volume function, def. So we're defining our function def cube volume. It has one argument provided to it, which we're going to call the side length. What does a cube volume? How does the cube volume function work? Well, it takes the side length that you provide it and cubes it, and then stores that in something called volume, and then it returns the value stored in that volume variable. Okay, so this is the definition stage, and then this is the function actually being called. So result 1 equals cube volume of 2, so that's going to call the cube volume function, providing it with the argument 2. 2 is going to be cubed, which is 8, and then we're going to return that 8 here and store 8 in our result 1 variable. Then we move on to the next line of code, which is result 2 equals cube volume of 10. So we run off to our cube volume definition, providing it with the side length of 10. 10 cubed is 1,000. 1,000 gets stored in volume. Then we return the value stored in the variable volume, which is 1,000. We return it here in the line of code, and it gets stored in the variable result 2. And then we print out a cube with side length 2 has volume 8, and a cube with side length 10 has volume 1,000. Okay, so you might want to pause the video here and copy, these two grey boxes of code down, making sure include the colon, the proper indentation, and so on, and then run the code to check that it does what you expect it to. Okay, so here is just the syntax for defining a function. We use the keyword def, the name of the function written in CamelCase, and then any number of parameters separated by commas inside parentheses, and then a full colon, and then indented one line, the body of the function. Okay, so the function header is this top line. Def is the keyword to define the function. We have the name of the function, cube volume, the name of the parameter variables, so side length. If there were more, you'd have them as comma separated, then a colon. Then you have the function body, kind of like how you'd write a loop body. You indent this one level, and then you have volume equals side length cubed, and this return keyword will exit the function and return the result back to where cube volume was called in code in your program. Okay, so a couple of things for maintainability, just good design habits, for software engineers and things like that. Whenever you write a function, you want to comment its behavior. Again, these comments are for the human readers, not the compilers, and the comments should describe what the function does, what the function returns, and what parameters the function takes. So here are some comments, right? They're indicated by the hash symbols, so they're not going to be interpreted by the compiler. We have it's explaining what the cube volume function does. It computes the volume of a cube. Straight away, we understand what it does. It explains what each of the parameters are. So the parameters are side length, and that's the length of a side of the cube. Fine. And then what does it return? It returns the volume of the cube. Okay. So the function comments here are explaining the purpose of the function, the meaning of the parameter variables, and the return value. If the function had some specific requirements, we'd also include them in this comment section. Okay, so this is kind of a full Python program with all of the nice comments and properly laid out with proper indentation and so on. So initially, just some comments to explain what the program does. This program computes the volume of two cubes. We've defined something called the main function. Inside the main function, we have result1 equals cube volume 2, result2 equals cube volume 10, print a cube with side length 2 has volume result1, print a cube with side length 10 has volume result2. Then we've got some more information here, so some more comments describing what the cube volume function does. So the cube volume function computes the volume of a cube. The parameters that we provide it with are side length, which is the length of a side of a cube, and it returns the volume of the cube. And then finally, we actually need to call the main function to begin executing the program. Just like I said earlier, like if we just write down this def cube volume thing, it doesn't do anything because we haven't called it. It's the same with this main function. So we call the main function here on line 20, which then does the result equals cube volume 2, which calls the cube volume function and provides it with the argument 2, returns 8 to result 1. Then it calls cube volume on 10, provides the side length of 10 as an argument, cubes that, which returns 1,000, stores that value in result 2, completes the print statement. If you stop, pause the video here and copy this down and run it in full detail with all the comments all nicely laid out, you will see that the execution in your shell returns a cube with side length 2 has volume 8, a cube with side length 10 has volume 1,000. Okay, so the main function, which is this one here, which we've called at the very end, is commonly used in lots of programming languages. There's a reason we've called it main. But when defining and using functions in Python, it's good programming practice to place all of the statements in functions and to specify one function as the starting point. Typically, that starting point is given the main name. In other programming languages, it is a required function name, and it's just keeping up with almost tradition that we're going to keep calling it main here. We have to have one statement in our program that then calls the main function, which is this final bit on line 20. Okay, so this is the actual entry point to running the rest of our code. Okay, so how does this syntax look like for the main function? we have def main. By convention, main is the starting point of a program. Inside that, we've got result equals cube volume 2. The cube volume function is going to be called by the main function and is defined just slightly below. And remembering the function doesn't do anything until we call it. So at the very end of our program, we call the main function, which then gets us into our starting point for the program. Okay. So this statement here, this main call, is outside any of the definitions, any of the function definitions. Okay. It's important that you define any function before you call it. For example, if you try and run the following program, it's going to produce something called a compile time error. If we try and print the result from cube volume of 10 before defining cube volume of 10, before defining the cube volume function, the compiler doesn't know what the cube volume function is, and will throw an error. Okay, so even though we've still defined it later on in the code, because we haven't defined it before we've called it, it's going to lead to an error. So if you kind of look at this set of code here, we define all of our functions first, and then we call our main function. Okay. However, the kind of caveat to that is a function can be called from within another function before the former function has been defined. So we can call cube volume from inside the main function definition before we've actually defined cube volume, because we're not running the main function here, right? We're just defining it. So we're saying, hey, we're defining the main function to do this, this, and this, and we're defining the cube volume function to do this, this, and this, and now we're going to go back and call the main function. Okay, that's perfectly legal and wouldn't cause any problems. What might be interesting is to kind of pause the video and move this main function call just above the definition of the cube volume function and see if that makes any changes. Okay, we know if we move the main function call right to the top, we're going to get a problem because we're going to try and call the main function before defining it. What happens if we've defined the main function, but we haven't defined the cube volume function yet, and we just fit the main function call here. Okay. So kind of almost to finish us up for this session, we have our call. We've got our arguments, and they're being used in the program. Parameter variables receive the argument values supplied in the function call. So the side length variable receives the argument value supplied to it in the function call. So in our example here, side length, the parameter variable, is going to be assigned the argument value 2. Okay. The argument value may be the contents of a variable. Maybe we'd called side length on a variable named like side length of box, which we defined to be like 25. So it could the argument value could be the contents of a variable. It could be the literal value 2, just as it is here. That's kind of where the argument value could come from. That's the sometimes called the actual parameter. It's the argument. Okay, the parameter variable is this idea of side length. It's declared in the called function. It is initialized with the value of the argument value that's being passed to the function, and it's used as a variable just inside the called function. Sometimes it's called a formal parameter. Okay, so the parameter variables receive the argument values supplied in the function call. Okay, so to kind of look at that in a bit of detail, result 1 equals cube volume 2. The 2 here is the argument value. The side length is the parameter variable. So the parameter variable side length gets assigned the literal value 2. Then we do 2. This shouldn't be times, it should be cubed, it should be double asterisks for cubing. 2 cubed is 8. That gets assigned to the value volume, and then we return the value stored in the variable volume, to here in our lines of code, which is 8, and then 8 gets stored in the variable result 1. Okay, to go through that again, we call the cube volume function with the argument value 2. The parameter variable side length gets assigned that argument value, so side length equals 2. Then we do the next line, our lines of code, which is volume equals side length. There should be a double asterisk here for cubed, or to the power of. So it should be 2 cubed, which is 8. 8 is this right-hand side. It's stored in the volume variable. We then return the value stored in the volume variable back to where the cube volume function was called, and then we assign 8 into the variable result 1. Okay, so that's kind of our first introduction to functions and the idea of passing parameter values into, argument values into parameter variables, how you define them, the special keyword. It's definitely worth pausing the video, maybe rewinding through things, and trying out some of these functions, getting used to writing out the syntax, and trying to follow through by hand maybe how they run. We will continue with functions in the next session, and then we've got one final session to finish off, which will be a long one on lists. I hope this has been useful, and I will see you in the next one.